Good day, everyone. This presentation includes my airline flight delay analytics dashboard. The deck has been redesigned with a aviation operations style so that it feels relevant to airline operations and dashboard analytics. The project uses the 2024 delay data set selected from Assessment 1 and focuses on three practical questions: where delays occur, when disruptions become more serious, and why they happen. I will explain the project objectives, dashboard design process, challenges, solutions, a demonstration flow, and a final learning outcome. The project topic is flight delay visualization. Delays matter because they affect passenger satisfaction, aircraft utilization, airport congestion, crew planning, and airline cost. The first objective is to benchmark the airline and airport reliability using indicators such as average departure delay, average arrival delay, cancellation rate, and delay flight percentage. The second objective is to detect high-risk periods by month, day of week, departure time, band, and the third objective is to diagnose delay causes such as carrier delay, weather delay, NAS delay, security delay, and late aircraft delay. These objectives make the dashboard useful for operational decision making. The data source is the Kaggle flight data dataset by for 2024 by Harshit Patel, which was also selected in Assessment 1. It is appropriate because it contains operational flight fields such as scheduled and actual departure and arrival times, elapsed times, taxi times, and route distances. It also includes disruption indicators such as cancellations, diversions, departure delay, and arrival delay. And most important, it also includes specific delay fields which allow the dashboard to explain why delays occur. Because the dataset combines categorical dimensions and numerical measures, it is suitable for Tableau visual analytics. The target audience is airline operations managers, airline management teams, route planning analysts, and customer experience teams. Airline operations and managers need to know which part of the network which is performing poorly, and airport managers need to understand congestion patterns and high risk time windows. Route analysis need to compare carriers, airports, and operating periods. Customer experience teams need to inform the anticipate disruption and communicate clearly with passengers. This means dashboards must be fast, interactive, and easy for non-technical users to interpret. The visual design is inspired by an airline operations control dashboard, uses dark cockpit style interference, KPI cards, alert colors, and aviation theme map. And it supports analytical narratives. The dashboard shows exactly where the reliability issues are concerned, and it shows where disruptions peak. It also explains why delays happen, and managers decide what actions prioritize the scheduling buffers, airport resource planning, and contingency communication. The design was done through iterations. Exploratory charts were used in to understand distributions, outliers, and trends. In the second iteration, visuals did not support the research questioned and was removed. In the third iteration, dashboard was arranged into KPI, comparison, temporal, and causal zones. And the next iteration would be the color labels, tooltips, filter placements that were improved. And it becomes visually modern while still analytically coherent and easy to present. For the live demonstration, I would begin. with the KPI cards to show the overall reliability picture. Then I would apply filters for airline or airport demonstrate interactivity. Then I use ranking charts to identify high delay carriers or hubs. Then inspect monthly line charts or heat maps to show when delays are most serious. Then I would review delay cause charts to determine whether delays are mainly internal, such as carrier or late aircraft delay, or whether it's external, such as weather or NAS delays. Finally, I would reset the filters and summarize the overall operational story. The dashboard can reveal several practical insights. It identifies the airlines and airports with high delay or cancellation risk. It shows disruption, whether it increases in a particular month, week, or time bands. It can also reveal network effects, such as evening flights experiencing accumulated delay from earlier disruptions. The delay cause analysis helps to identify whether the issue is carrier related, weather related, NAS related, security related, or aircraft related. And the value of the dashboard is that these insights can be converted into actions such as security buffers, schedule buffers, staffing improvements, turnaround control, or contingency planning. The main project outcome is an interactive dashboard concept for airline delay analytics presented using a modern operations control design. A key learning is that visualization quality depends quite heavily on data cleaning and calculated fields. Another learning is that dashboard layout should follow the user's decision flow from the overview to the detailed diagnosis. I also learned that strong visual design is valuable only if it preserves analytical clarity. And finally, interactivity is what turns static charts into decision support tools because users can filter, compare, explore the data based on their own operational questions. Future enhancements that could make this project more advanced would be to add passenger volume, revenue, load factor, or customer complaint data that would help estimate the business impact of delays. Adding aircraft type, turnaround time, gate allocation, and crew data would support deeper root cause analyses. A predictive delay risk scoring could estimate future disruption before it happens. Real-time data feeds could make the dashboard useful for live operations monitoring. And finally, the dashboard could be adapted into mobile and executive summary versions for different stakeholder needs. Thank you.